Okay, let's do some math for fun, and today I have something that you probably have not thought about before on a right triangle. So let's have a look. Suppose we have a right triangle with these two legs being A and B and C being the hypotenuse. Well, firstly, I would like to tell you guys that this is fact number one. Well, if you just add A and B together and notice that these are just the first powers, and if you compare that with C, then which side is going to be bigger? Well, it will be A plus B, because this is known as the triangle inequality. It's actually true for all triangles. Whenever you add any two sides of a triangle, it has to be greater than the third side. So let me write that down real quick. Triangle inequality. Cool. Now, if we are talking about the second power, of course, this will be fact number two. A squared plus B squared and compare that with C squared. Well, this miraculously, they are equal. And of course, this right here is known as the Pythagorean identity. I mean Pythagorean theorem. Identity is mainly for sine cosine. And I do have a proof for this where I use a similar triangle. So if you want to see that, the link will be in the description. Now, here is the question. You probably can guess at what we are going to talk about today. Now, what if we have A to the third power plus B to the third power and compare that with C to the third power? Have you thought about this before? Which side is bigger, or maybe they are secretly equal to each other? Well, I don't know. You should go ahead and pause the video right now and try this first. Done? Okay. Let's take a look. Firstly though, A, B, C, they are on the side of a triangle, so we can say that they are all greater than 0. That's all we are going to consider, and they are all real numbers. So we can do the following. Firstly, since C is the hypotenuse, then we know that A has to be less than C, because that's the longest side of a right triangle. And we also know that B has to be less than C. Cool. Okay. Now, how are we going to get to the third power though? Well, if you look at this side, why don't we just multiply both sides by A squared? Can we do that? Sure thing, because A squared is for sure positive, and we can multiply it, and we will just get A to the third power, and this inequality will stay. It's going to be less than C times A squared. And, of course, why don't we do the same thing? If you want to get B to the third power, just multiply B squared, so we get B cubed. It has to be less than C times B to the second power. Now, combine this and that. We can just go ahead and add them up. This right here, A to the third power, plus this right here, B to the third power, it has to be less than this plus that. CA squared plus CB squared. And of course, this right here, they both have C, so this is equal to C times A squared plus B squared. And of course, this right here is C squared because of the Pythagorean theorem. So all in all, the right hand side is equal to C to the third power. And remember, here we have a less than. So we are saying that A to the third power plus B to the third power, it's actually less than C to the third power. Yeah, that's the answer. Pretty surprising, right? And of course, I did this for you. You know what's coming on next, right? Here is your question. You try this and let me know what the answer is. Of course, let's do the fifth power. A to the fifth power, no, just kidding. Let's do the fourth power. Plus B to the fourth power, compare that with C to the fourth power. What's the connection between this and that? Or maybe they are equal, or maybe we don't have enough information to compare them. I don't know, I haven't tried it. You can let me know.